Hey everybody, Chris Granger here with Electrical Equipment Company. I'm very excited to have with me Mr. Jeff Kimmel from RL Mattis. And today we're going to be talking about how you commission a variable frequency drive. And no better way to learn that than from the experts. So we brought in Jeff. I'm very excited to have you guys here. So how you doing today?
Just great.
So Jeff, talk to us, man. How do you get started with commissioning a drive?
The best part of the Yaskawa drive is that you can pretty much plug it in and press run.
Nice.
The smart thing to do, though, is some investigation beforehand.
Okay.
One of the things you want to do is confirm you're going in the right direction. Your motor is turning in the right direction. The best way to do that is simply to have someone observe the motor and press jog.
Okay.
The jog is at 6 hertz, so it's a real straightforward process. If you're going the wrong way, there are a couple different ways to remedy that. The first way, the right way, is to change T1 and T2 either at the drive or at the motor conduit box. The other way, if you're in a big rush, is to simply change direction of rotation in the software.
Gotcha. So make reverse forward and forward reverse.
Exactly, but that's dangerous very often because the next guy that 20 years down the road that changed the drive doesn't know you did that.
So what if it's coupled? How does that factor in if you can't do that?
Well, you need to find out what direction of rotation you're going.
Got it. Yep.
It'd be worth uncoupling it.
Gotcha.
Or, again, we're going at 6 hertz, so it shouldn't make that much of a difference in most applications.
Okay. All right, Jeff, what next?
Well, once you've determined all of that, what we need to do is auto-tune the drive.
All right.
Now, we can do this one of two ways. We can operate off the computer if you have one handy, or for some of us old timers, we simply like to just go right off the keypad.
All right.
Now, what we really want to know is what the motor full load amps is, what the motor kW is, what the RPM is. We simply put that information into either the computer program or we simply key that in to the keypad.
All right, Jeff, that stuff sounds really cool. Maybe do you want to show us how you do the auto tune on the drive itself?
Be happy to.
All right.
The first thing that we need to do is take a look at the motor nameplate and make sure you have that information handy.
Gotcha.
Oftentimes the motor nameplate is far away from the drive, so it's always best to either take a photograph of it these days or simply write stuff down. So what we've got here, this is the GA800 keypad, and what we want to do now is auto-tune the drive to the motor. So we've got our information here, so we simply go menu, right down here where it says auto-tuning, press enter. Okay, motor parameter tuning is what we want. Stationary line-to-line resistance is what we want in this case. So it is a 1/4 horsepower motor, so we say okay. It is 1.15 amps, so we say okay. And pretty simple, run key, tuning start. It does a quick auto tune which teaches the motor details to the drive, so you get the optimum performance out of your system. This only takes a minute or so, but the benefits of auto tuning in most applications far outweigh the couple minutes it takes to do it.
All right, Jeff, that's really cool. So should you always do an auto tune?
If you can and you have the time, you should do an auto tune.
Okay.
Now let's talk a bit about auto tunes. The best way to do an auto tune is to do a full rotational auto tune without the load connected. If you have a load connected, you should not do a rotational auto tune, but do a static auto tune. To maximize the effectiveness of the drive, that's when you do an auto tune.
Okay. Now, from my motor repair days, what happens when you actually change the motor and not the drive? Should you do an auto tune then if a motor gets changed?
Absolutely. It will, especially if the motor gets changed. That's
Okay.
a great opportunity to do so because it's uncoupled and unloaded.
Right, exactly.
Yeah.
And sometimes with windings, I just know from motor to motor, the windings changed. From a design standpoint, I would assume that would impact the drive.
To some degree, yes. And specifically if the motor's rewound, that can make it much more necessary to do an auto tune.
Okay. Very cool. Very cool.
Great.
So that hands-on works great. What if we had the computer, and how would that process work?
It'd be very similar. You would answer those questions, connect to the drive, of course, and then answer those questions.
Okay.
Let's give an example.
All right. Sounds good.
It is always good to plug in via USB Mini into the drive, and we have Drive Wizard Industrial, which is free off of Yaskawa.com. And I'm going to open that up and give it a name of the project called Eco. I'm going to say OK. And then we want to go online to the drive, and it's literally a one-click process.
That's so cool.
So now we are online with the drive. I'm going to go up here to Startup and Diagnostics and go to Motor Tuning. This is the drive we're connected to, and I'm going to say OK. Just like before, I'm going to do a stationary auto tune. I go to Next. It asks me some questions, and I say Next. It is a 0.25 horsepower motor, and the current is 1.15 amps. Next. Run. So that's how it auto-tunes through the computer. Again, it's 6 of one, half dozen of the other. If you have a computer handy, you can benefit from using it later, but from auto-tuning, it's an extremely quick process from the keypad. So tuning is successful. So transfer tuning data to project, click on that, and we're okay.
So we've auto-tuned it on the keypad at the drive itself. We've auto-tuned it here through Drive Wizard, which is really cool. So what's next in the commissioning?
Next in the commissioning, since we already auto-tuned it here, and we gave it the full load amps, that sets a parameter called E201, which is the motor full load amps. If you are in a rush and you cannot auto-tune it because the boss is on your back, please put in E201 right off the nameplate. It is the motor full load amps. Now, one of the things that's great about a Yaskawa drive is it's already set up with all necessary parameters to run straight away. What I always recommend is we run it in local, and that will take out any discrepancies with wiring or communications. So what we want to do is run it in local from the keypad, which is nothing more than giving it a frequency reference. And what we want to do here is check for vibration of the process and things of that nature. What we don't want to have is a vibration of your machinery at a particular range of frequency.
Okay. So you kind of move that up and down to check that vibration through the spectrum.
Exactly.
Okay.
And typically what I do is I started at 10 hertz, go for a while, go to 20 hertz, go for a while, 30 hertz, all the way up to 60.
So 10 hertz jumps, you found that to be effective?
I have.
Okay.
And honestly, you don't see the vibration often, but when you do, you never forget it.
Mm-hmm.
And we have a programming method to skip those frequencies such that the vibration will never be felt in your machinery.
Very cool. Okay. All right, so that part, we've got that step done. So where do we go next?
Well, actually, next you need to learn a little bit more about the application. What kind of acceleration and deceleration times are you looking for? We are factory set at 10-second accel, 10-second decel. We're factory set at ramp to a stop. Those are the various things that we typically have to deal with. If your customer needs a longer acceleration time, we simply change the parameter C like Charlie 01 to a value greater than 10 seconds. And we can go up to hours of acceleration, which is very rare that you would need such a thing.
Wow.
Likewise, the deceleration. Oftentimes, deceleration at 10 seconds may not be satisfactory. You may need to increase that deceleration. Because again, even if you're coasting to a stop, deceleration will change when you change your frequency reference. It follows that deceleration. Now, we need to wire it up depending upon how you're going to do the control. It is factory set to wire to accept digital start stop
Okay.
and analog reference. That is the factory setting. If you want to change that, we can change the parameter B like Bravo 1-01 and B like Bravo 1-02, which will allow you to select different locations, different sources, I should say, for start, stop, and for reference. In this demo here, we have a Redline HMI talking Ethernet IP, the same communication that you would use to talk to an Allen Bradley PLC. The drive talks to the Redline through this switch, and it's talking Ethernet IP. I could have it receive its signals from this HMI just as easily by changing B101 and B102 to the value 3.
Sounds good. All right. Now what?
Well, frankly, typically we just run the drive for a while and make sure that everything in the system is operational. Now, I mentioned if we're dealing with Ethernet IP, Profinet, Profibus, DeviceNet, any of those other communications, we need to have IP address information available. That's a good thing to have, just like the motor nameplate information when you start up.
Mm-hmm. Okay. Now let's say from a wiring standpoint, you just mentioned how to wire it. So if I'm commissioning a drive before I start, powering up, are there any conditions or things I should inspect for to make sure the wiring's been done properly before I do any
Heavens
power?
yes.
Okay.
Heavens yes. And again, if oftentimes we don't do the wiring, a contractor has done the wiring. You want to make sure that terminal S1 for start forward and SN has a good connection. SN is our common, S1 is forward run, S2 is reverse run. Make sure those are solidly connected. If you're dealing with analog input reference, A1 is factory set for 0 to 10 volt input. A2 is factory set for 4 to 20 milliamp input. If you've got 4 to 20, simply connect to A2 and AC. And one of the great things about Yaskawa products is every drive wires the same. So if you've wired one, you don't have to change anything to wire the next one. How's that possible? Because Yaskawa makes all of their own drives up in Chicago for the Western Hemisphere.
Wow. Okay. Now, let's say it's in the middle of the night, Jeff, and something does happen, and I'm that technician and needs to change it. What's involved there? Is that just basically just taking the wires, unhooking what's there, and just hooking it up and hitting start? I mean, so far as that change out, how does that work?
One of the smart things to do when you start up a drive is to take the program that you've developed for that drive, i.e. the change of full load amps, the change of speed reference, things of that nature, and put it into the keypad memory. And that's a real simple manner that I'd like to show you.
Okay.
Now what we want to do is put the memory into the keypad. So all I'm going to do is press menu and tab down until we see, in this case, just parameters. And I'm going to go up to see keypad related settings. I'm going to press enter, and I want to go down here to copy keypad function. Press enter, and I simply want to put in the standard parameters that we've changed into the keypad. And I want to say, I want to put it in this location, overwrite that, and you're done. So now the memory is in the keypad as well as in the drive.
All right, Jeff, so Drive Wizard Industrial, that looks really cool. A lot of great things you could do with that for sure. So maybe we'll just wrap this up here from a commissioning standpoint. Any parting advice? I know you've been doing this for a long time, started up more drives than most people will ever have to in their career. But
True.
Any advice for the people who still may be a little intimidated with starting up a drive?
The reality is, it's a lot easier than people make it sound. With the Yaskawa drive, we want to check rotation direction. We want to run it in local. We want to set full load amps. And we want to press run. From a wiring perspective, forward run is terminal S1 to SN. Frequency reference, if you have a 0 to 10 volts, is A1 to AC. If you've got 4 to 20 milliamps, it's A2 to AC. If you want to have an external fault, something happens that's not a drive problem, but you want to shut the drive down, that's S3 to SN. If you have that, you probably want to reset it. That's S4 to SN. All of these are factory settings that all you have to do is press run. Thanks.
Very good, very good. So for those watching that want to learn more, we have the team of experts. We can come out. We have demos available. We have the lab built here in Raleigh. We have a lab built in Greensboro with the Yaskawa drives as well. Love to show you. Come by, put your hands on it. Jeff likes to go out and talk drives. Any questions, let us know. Let us know your feedback, and thank you for taking the time with us today.
Thank you all.